Hello there. So in this lesson we're going to be continuing on from the player movement video that I've done. So in that video we had player moving left and right and being able to jump. In this video we're going to look at creating an enemy such as the one here. When you're not close, it's just going to move around in some kind of general circular movement. And when you go closer, he's going to get attracted to you and follow you. And then when you leave him alone, he'll stop following. In the previous video as well, we did it then if you died, you'd respawn. But yeah, so today we're looking at getting this enemy to move in a circle and chase you when you come close. So let's start. To start with, I'm going to delete everything that I've got, and we shall start from scratch. So all we need is all we need to do is start off with, let's create a 3D object, a cube, and let's call it enemy. We are also going to tag it as an enemy. We did this in the last video. We had spike or enemy, whatever you like. You just add tag, add a new tag, enter in the name, and then you can go back on your object and click on your tag. So we're going to use our enemy tag for this. And then we're going to right click down in the project. We're going to create a new C# script, and then we're going to call it enemy. Here we go. Here's our enemy script. Actually, we'll come back to this in a second. Real quick, we're just going to drag our enemy script, so click and drag, and pop it into our enemy cube. So you see now it's got the script on it. So there's a few things that our enemy is going to need. First off, he's going to want to be actually on the platform, so let's move him to 0, 0, 0. This is our player. Oh, that's not our player. This is our player. So we're going to move our enemy a bit further away from the player, just so then it's not going to be attracted to us straight away and try and follow us straight away. I use 5 left and right of the player, so you see there's like 8 away, so 8 or 9 away, so that'll be fine. He won't chase us to start off with. So just get your enemy in the scene so he's a bit further away from the player, and let's jump into the code. So you can double click the code and it will load straight up. What we're going to want to do is going to delete all of this, so we start with a fresh blank document, just then you can see exactly what I'm adding when I'm adding it. So an enemy, what does it need? We need to know if the player is close. Oh, already, there we go. So what we're going to do is we're going to get a reference to the player. So the player is a game object, and we're going to call it player. So we've just got a reference to a player, and we can save it as here as a game object type. We're also just going to specify actually this is a private game object, just because we don't want it in editor. So in editor we put public and you'd be able to see it in editor. And by editor I mean Unity's editor. We're also just going to set up some quick values just for its movement and whilst it's chasing the player, how far away it's going to be from the player before it starts chasing, and maybe it's when it's not chasing in the circle, we'll set up a value for that too. So let's make a private float and let's call it move speed. So this will be when he's chasing the player. So I currently, on my player controller, which we made in the last video, we made a move speed for the player of 10. So I want my enemy way slower than that. I don't want this to be difficult. I just want to see it working. So I'm going to pick 4. Remember I put F because it's a float. Okay, now let's make another movement. So let's do a private float and let's call it idle speed. So this is for when the enemy isn't chasing the player. And we're going to set that to 1 because I want it even slower. I just want him chilling. Going to make another private float, and this is for how far away the enemy can see the player. So I'm going to say this is follow distance. Maybe tether would be a better word, but okay. And I'm going to set this to 5f, just because that's a nice number. And then I'm going to make a private float x, and I will explain that later. It's just a temporary variable. Anyways, let's start. So we want a start function to kick things off because we have our empty box to save our player in up here. However, we haven't actually saved the player anywhere. We haven't said this is the player, this is the game object that is the player. So we're going to say player equals game object dot find player. Now this is very handy but also very taxing. If you have thousands of game objects and you say find player, it's got to look through the hierarchy as in this part here, and it's got to look through each object and go, is that the player? No. Is that the player? No. Is that the player? Ah, yes. Capital P. That's the player. That's correct, like capital letters and everything. This is the object that he's talking to. But if there was thousands of objects, you could see how that could be taxing. Another thing you can do, just for note, is you could do GameObject.find with tag, and you could specify a tag, which is a much better way of doing things. However, just because we've got a smaller game right now, I'm just going to do find. And I'll just quickly show you actually. If you put dot find, you can see all the different types that you can get. So the more specified you can get, the better. So you could find like game objects with tag and it would find all the objects with the tag. Or find game object with tag and it would find the first game object with tag, whatever you're looking for. Just some things to note really. But anyway, we just want to find our player from the hierarchy and say this box is now our actual player, which is fantastic. Now, let's talk update functions. So we want our enemy position plus and minus our follow distance. And then if the player is within that range, then the enemy will attack the player. So what we'll do real quick, just to make things easier to read, we're going to make a float and we're going to call it x max, and we're going to set that equal to the enemy's transform dot position. So this game object's transform position dot x, so it's x value, and we're going to say plus follow distance. So the maximum view, like where you can see the player ready to chase him, is its current position plus 5. And then I'm going to do Control D to duplicate the line, and I'm going to put minus, and you guessed it, this is now x min, so the minimum value. Okay, next up is let's actually check if the player is within this range. So let's check our player, which we have a reference of, and let's check his position, or them, they, player transform position, and we're looking at its x value, and we want to know if it is larger than the x min, but we also need it to be within the two things of min and max, so it's got to be larger than the minimum but smaller than the maximum. Smaller than the max. Oh, x max. Okie doke. So if it's within that range, let's make the player chase. Oop, vector 3. Chase the player. So we're going to take the player's position minus our position, and that should give us the difference between the two, so then it will give us like a direction to move towards. So if it was the player is on the left, it would work out that the player's on the left, and then we can use that to move us towards that way. So let's say move towards equals player dot transform dot position minus the enemy's transform dot position. So that is finding the difference between the two. And then we will say update our position. So let's add to our position our move towards, and let's normalize it. Just so then, if you imagine the player is like really far away on the y-axis or something, and because at the moment we're only checking the x-axis, it would move on the y-axis really fast, because it would be like 100y, and then it would be adding 100y all the time. So if we normalize it, it puts it all down to a plus or minus scale, so it's just going to be +1 or -1 depending on which direction it is. So that gets rid of the worry of like the enemy being way too fast. Times it by time.delta time because we want smooth movement, and then smooth. We want it times by move speed as well, just so then we can change the speed as we go. So that should all now work. So what we'll do is we'll add an else. So this is for the idle movement. We will do x plus equals time dot delta time, which I will explain in just a second once you've written out the code. So transform dot position plus equals new vector 3. So this is now, it's idle and we want it moving in a circle. Now, bit of cool maths here. What we can do is mathf dot sin, put some brackets in, and we can put x, so that our x-axis is going to be based off of a sine wave, and then our y-axis, oh not sin, cos, is going to be based off of an a cos wave, cosine wave, and we're going to add 0.5f to it. And that will make a circular shape, and you'll be able to see that in game, which will be very cool. And then let's just times it by time.delta time, and let's also times it by our idle speed. Again, so then we can vary how quick it moves. So float x, let's explain float x. So float x is used because we want to do sine and cosine waves, and we need an increasing value throughout the whole time it's going to be doing this circular movement. So then it goes through the sine in cos, which is -1 to +1, which means it will always be looping between -1 and +1. And we've done the math like across, and it's going to go in a circle. I wouldn't worry too much about that, and I think I've probably explained it badly, but as long as you've written that in, I'm not going to go through cosines and things with you and why that works. Anyways, we can see it is now, this is our enemy moving in a circle, which is fantastic. And when we go near, it's going to chase us. Oh. And if we leave it alone, it will stop chasing us. Let's try and run away from him. But awesome. He does clip through everything, but that's okay. I wouldn't worry too much about that. Oh, I died. Just for a basic enemy that chases you, that's great. We could also, so I quite like the functionality of doing it in a circle. However, if you wanted to, you could get rid of all that code and you could just have it. Oh. So then your enemy, let's pop him closer to the floor so it looks a bit more realistic. it's just a sitting target, and then when you go towards them, he'll chase you until you get away from him. Of course, except we've still got him on the x-axis, so he is a flying enemy, which is why I've put in the circular movement. That is an enemy chasing you. Well, at least a flying enemy chasing you. I think what I'll do now, actually, now I've just demonstrated that, I kind of want to show you an enemy that stays on the floor. So should we do that real quick? We'll do, we've got everything set up for the X and Y and all that. However, what we really want is it for not to take into account of the Y position, so it doesn't move up and down. So on our move towards, let's do this. Same thing pretty much. Let's comment out that line so we can do both. But our move towards, let's do this as a new vector 3. And let's put, oh, I need to copy. I'm going to copy this in for our X position, and then let's put transform.position.y, transform.position.z, so it's just going to keep the same Y and Z, and then we'll just add in X to the X position, so then it's only working out the X position, as in the difference in X position. And then if we have a look at this, did I save? Oh, you know what else I didn't do? Let's remove that for a sec. Here we go. So it's not going to move in circles, and it should only now... Do you think I did something wrong? We don't want it adding its X and Y position. We only want it comparing the X's. We don't want Y and Z, we just want it comparing X's, and now that will work. Because it was adding the Y position all the time in the X. There we go. And then if we jump, he's not going to follow. He's just, oh god, oh, I'm going to die. No, no, no. Oh, there we go. And then he'll stop chasing. But he'll only chase us in the X-axis now rather than both, which is cool. Thank you very much for the lesson. Hope you enjoyed. And I'll see you in the next one.